All right, so now we're going to go ahead and we're going to try one more problem where we find our second derivative for implicit differentiation. And then we're going to look at some different problems that could be asked of you about implicit differentiation, which aren't like you know how to do them, but because they look overwhelming, you'll panic. So let's talk about it. First, let's do this one though. It's a little refresher. So if you're finding your second derivative, the first thing we have to do is we have to find our first derivative. And so you're going to need to take the derivative of both sides of your equation with respect to x. Careful here, we're going to have to do a little bit of product rule. So you got your x cubed and your y cubed. So I got x cubed y cubed, so derivative of that would be 3x squared, derivative of that would be 3y squared, dy dx. No, it keeps clicking, stop it. And then we're crisscross applesauce, so on the left-hand side we would have 3x squared y squared dy dx plus 3x squared y cubed. Oh, this should be a cube right here. I was like, we're missing a cube. There we go. Okay. And then on the right-hand side, we get 0 because the derivative of 5 is 0. So now let's go ahead and we're just going to subtract this piece over. So we'll get 3x cubed y squared dy dx equals negative 3x squared y cubed. And then we divide by this stuff, so we get dy dx by itself. So we'll get negative 3x squared y cubed over 3x cubed y squared, and we can actually reduce that quite a bit, can't we? So 3's cancel. I'll be left with one y on top and one x on the bottom, so we'll just have negative y over x. Oh. My hand's on the undo button. There we go. So there you go. That's your first derivative. So now we're going to go ahead and do our second derivative for this piece. Excuse me. So we'll take the derivative of my left-hand side, so I'd get my second derivative with respect to x, and then right-hand side I have to use quotient rule. Low, d high, oops, minus high, d low, all over low squared. And remember, anytime that you have a dy dx, we want to actually replace that with what it's equal to. So I'm going to go ahead and plug in this piece. So we'll have negative x times y over, oh, I guess it's a negative y over x, isn't it? Minus y all over x squared. So then really we would get our x's to cancel. So we'd have negative negative y, so you get y plus y, oops. Oh no, y minus y, we got it, over x squared, which would be 0. So your second derivative is 0, which is fine. You can get that. I know it feels like a lot of work for not a lot of reward, but it can happen. All right. So now let's go ahead and we'll look at some implicit differentiation problems that, again, you know how to do them, but you panic. So find the points at which the graph of that stuff has a vertical or horizontal tangent line. So a couple of different things that should jump out to you. Tangent line, right? We would usually like to write the equation of the tangent line, but it doesn't say that, right? It doesn't say find the equation of the line tangent to the graph or the equation of the tangent line, but it does ask us where we have vertical or horizontal tangent line. Now, if I have a vertical tangent line, that means that the slope of that tangent line would have to be undefined. Right? And what's the only way that we can get a number undefined in mathematics? Well, it's when you have some number divided by 0, right? And so then we're going to be looking for where the slope of our tangent line has a 0 in the denominator, essentially. Horizontal tangent lines, on the other hand, would have a slope that's equal to 0. So that means that you would set your slope of your tangent line equal to 0 to find the points where that happens at. Now, what is the slope of our tangent line? Well, the slope of our tangent line would be the derivative. Yay! If you can't guess, if I haven't guessed yet, a lot of calculus has to revolve around the derivative. So we're going to find our first derivative of this, and then when we want to find the points where that it has a horizontal and vertical tangent line, basically we're going to set our derivative equal to 0 to find the points where you have a horizontal tangent line, and then we'll set the denominator of our derivative equal to 0 to find the points where your graph has a vertical tangent line. So let's do it. Let's go ahead and find our derivative here. So 25x squared, so that'd be 50x plus 32y dy dx. We're still using implicit differentiation here because this is not solved for y. Plus 200 minus 160 dy dx. And then 400 is the derivative of 400 is 0, derivative of 0 is 0, so we got this. All right, move everything to one side that has dy dx's, and everything that moves to the other side doesn't. And then I'm going to be extra tricky here, and I'm just going to pull out my GCF of a dy dx first. So the 50x will go over, the 200 will go over, and then so the stuff that's left, I have a 32y and a minus 160. So that will be what's left over when I pull out the dy dx. Then on this side, I have negative 50x minus 200. Cool. All right, so then my dy dx, my first derivative, oh, I think I can reduce all of that by like a lot. Let's see, we can't all divide by 10. Can they all divide by 4? Not 50, I don't think. How about 2? Yeah, 2 is going to be the thing. So we'll end up with, well, we would normally end up with negative 50x minus 200 over 32y minus 160, but all these numbers can be divided by 2. So then I would have negative 25x minus 100 over 16y minus 80. Okay, so that makes it a little bit smaller numbers and easier to deal with. All right, so let's do it. We're going to figure out the points where this happens. So let's first look at, we'll do vertical tangent lines first. So for vertical, we're going to go ahead and set our denominator of our derivative, our slope, equal to 0. So 16y minus 80 equals 0. And so then we'll figure out what y value would make that true. Let's see, 80 divided by 16 be 5. So when my y value is 5, then I would have a vertical tangent line. Now, that unfortunately, it does ask us for the point. So if I have a y value, how do I find my x value? Well, you have to substitute it back into your original. Function, or excuse me, original equation to find that x value that belongs with this y value. So we'll do that in a second. Let's go ahead and we'll look at my horizontal tangent line. I'm just afraid I'll run out of room. So for my horizontal tangent line, I have to figure out where my numerator equals 0. So negative 25x minus 100 equals 0. Well, that happens at x equals what, negative 4. And so we'll do the same thing, is that if I want to find the actual point where this occurs, I found the x value, so to find the y value, I have to sub into, that looks like one word, your original. All right, so let's go ahead and we'll do that for each of these pieces. All right, so I'm going to try and use this little space as possible. All right, so 25x squared plus 16 times 5 squared plus 200x minus 160y, oops, y is 5, plus 400 equals 0. So let's see if I can't simplify that a little bit. So it looks like we have 25x squared, then I have 200x, and then let's see, 16 times 5 squared minus 160 times 5 plus 400. Oh, that's it. That's all it gives me. Because believe it or not, this stuff cancels out with this and this. Beautiful. All right, so now, whoops, we're going to go ahead and solve for the x values where this happens. So then if you pull out, let's see, 25x, you're left with an x plus 4. Right? Cool. And so then your x values where this would occur at would be at 0 and negative 4. Okay, so then we have the points where we have an undefined slope. So the points where this would happen for a vertical slope or undefined slope, I'm gonna put my answers up here, would be 0, 5 and -4, 5. Okay, now we're gonna do the same thing with our x equals -4. Now, real quick though, we got to notice one thing, and that is that x equals -4 turned up as an option over here. So which one of these dominates which one of the other ones? Well, it actually turns out that undefined slopes dominate, because you could have the top equal to 0 at the same time that you have the bottom equal to 0, but as long as your denominator is 0, that's a dominating piece for slopes, right? So we'll say that this x value with that particular y value would produce an undefined slope, but there could be another y value that we're missing, so we still have to plug it in. So we'll get 25 times -4 squared plus 16 times y squared plus 200 times -4 minus 160y. I don't know, we're going to run out of room. Plus 400 equals 0. Wait, I can make that prettier. Hold on. Or I have to do another video anyway. I don't know if it's prettier, but I like it better. So plus 400 equals 0. Okay, so then let's do this. We end up looking like we have 16y squared minus 160y. And then if I plug in those numbers, 25 times -4 squared plus 200 times -4 plus 400. Believe it or not, we get 0 again. All right, so then you would end up with, let's see, plot GCF, 16y, y minus 10. Oops. All right, so then we have these y values. These are the other y values that would make my slope equal to, whoops, I guess I should put it down, equal to 0. I'd have a horizontal tangent line. So y equals 0 and y equals 10. So then my points for a horizontal tangent line would be my answers, would be -4, 0, and -4, 10. Right? So it was okay that this -4 appeared over here as well. So because this isn't a function, your x value can have way more than one y value. And so it's okay that the points -4, 5, -4, 0, -4, 10 all exist. It just depends on, you're just identifying which one of them would produce a horizontal and vertical tangent line. And so once you find your horizontal and vertical tangent lines, by setting the top and the bottom of your denominators equal, or of your fraction, the numerator and the denominator of your fraction equal to 0 separately, and you find your x and your y values, then you can always sub them into the originals to find their counterparts that match with them. All right, well, this is part 2, and so obviously it takes a lot of explanation to get through these, so we're going to do one more video to do 2 more examples. Or if you feel like you got it, you can go ahead and try it, right? Try to practice this once or twice.